Hello everyone, so welcome again to your science subject, and today our virtual lesson is on ionic and covalent bond. Again, we are your virtual instructors, Avon, Janiene Kilas, and truly yours, Hanielle. I hope that you're all ready and prepared. So let's start. So as usual children, before going directly to our topic, it is better for us to have a simple test first so that we can have ideas on our main topic. Okay? Alright. We have here pictures that helps us in our lesson for today, and let's guess them together one by one. Wait, we will set 10 seconds per picture before saying your guess answer, okay? Let's proceed to our first picture. So what do you think this image represent? If your answer is table of elements or elements, then your guess is right. How about this next image? What do you think this image represents? If your answer is among atom, electrons, elements, and transfer, then your guess is correct. What about this next image? What do you think this image represents? If your answer is among atom, electrons, elements, and sharing, then your guess is correct. So how many did you guess right? If you guess it right, then very good. But if you did not, still very good because you did your best. Okay, so our lesson mainly centers on the bond of chemical compounds. These are the ionic and covalent bond. Our key topics are the following. What is ionic and covalent bond? What is their difference? How can we determine ionic and covalent bond?
We have here our own objective. This virtual lesson is not just for me to discuss and for you to watch and forget. Instead, at the end of this lesson, I hope that we learn what is ionic and covalent bond, understand the difference between ionic and covalent bond, and the factors that determine their formation. Okay, now let's listen to teacher Janiene's discussion about ionic and covalent bond.
Okay, class, prepare your periodic table and any piece of paper for you to take down notes. Also, I hope that you will listen carefully to our discussion today, okay? If you felt that I am too fast discussing, it's okay naman for you to pause our video or preview it as long as you will understand our lesson. Alright, let's start. First, let's start our discussion on what is chemical compound. Chemical compound is any substance composed of identical molecule consisting of atoms or two or more chemical elements. When we say chemical elements again, class, yes, these are the elements that you can find in your periodic table. So we have here an example of chemical compound as you can see in the screen. The element sodium is combined with the element chloride. Then, they produce a product called sodium chloride. The product they produce is what we call the chemical compound. So, do we all understand what is chemical compound? Okay, that's good. Now, why are we learning about chemical compound? It is because it's connected to our main lesson. Let me ask you a question. How can these elements combine together? Is it possible to just randomly pick an element in the periodic table and pair with a random element? No. The combination of these elements has to do with the strong forces of attraction known as chemical bond. Chemical bonds are the connections or strong attractions between atoms in a molecule. As mentioned, in the atom, There are electrons or valence electrons that contribute in the formation of chemical bond. The presence of these valence electrons can determine whether an element may be bound with other element. So, do not forget that class, okay? In chemical bonding, we follow the rule named octet rule, which states that atoms tend to form chemical compounds in ways that give them 8 valence electrons, which means that an element should have contact to 8 valence electrons in a bond to ensure that atom is stable. Notice class that some elements are exception to the octet rule, include aluminum, phosphorus, sulfur, and xenon. Also, hydrogen and helium, because hydrogen and helium follow the do-it rule since their valence shell only allows 2 electrons. These elements will always hold a maximum of 2 electrons. For us to further understand the situation, let's have here the Lewis dot structure. As the name says, this is a structure for us to further visualize the ions and molecules of an element. We have here examples of Lewis dot structure of some elements. The Lewis dot structure of element helium, element barium, and element oxygen, and there are many more. As you can see in the screen class, there are 2 types of writing the structure. It is either like this or the dots only, but still they are the same. Then how can we know how many valence electron an element has in an easy way? So, let's have here your periodic table. We can count the valence electrons of each element by their periodic table group in which the element is categorized. Here, the vertical one. However, group 3 until 12 is an exemption, the transitional metals, because they cannot hold any more electrons. Okay, let's have here an example. So, let's find the Lewis dot structure of element N or nitrogen, which is categorized in group 15, which means it has 5 valence electron. Okay, let's write it. Next is the element B or boron in group 13, which means it has 3 valence electrons. So, by the example, does everyone understand now how to get the number of valence electron using your periodic table? Okay, that's good. And as we said earlier class, these elements are not stable because they don't have 8 valence electrons. That is why we need to bond them carefully with other element to be stable, okay? There are 2 ways in doing the chemical bond to satisfy the octet rule. It is by transferring valence electron by an element or by sharing valence electrons between 2 elements. This is where our main topic, ionic and covalent bond, appears. So, ionic bond. What is ionic bond? Ionic bond is the process in which transfer of valence electrons occur between a metal and a non-metal group of elements. Notice class that it specifically states that a process of transfer of valence electron between metal and non-metal group of elements, okay? So, let's have some examples. We have here compound potassium bromide or KBr. Let's go back to our periodic table. As you can see, our element K or potassium belong to the metal group, while element Br or bromine belong to a non-metal group. This sign already determined that they have an ionic bond. However, let's continue to do their Lewis dot structure for us to visualize the meaning of transfer of electrons. So, K or potassium belong to the first group, so it has 1 valence electron, while Br or bromine belong to the 17th group, which means it has 7 valence electrons. Then, to satisfy the octet rule and for the elements to be stable, we have to transfer the valence electron of potassium to the element bromine, like what you see in the screen. So the compound potassium bromine follows the description of ionic bond. So they have ionic bond. Another example, the compound magnesium bromide. Magnesium belongs to a metal group while bromine belongs to a non-metal group. Okay, let's do the Lewis dot structure. Magnesium has 2 valence electrons because it is categorized in the second group, while bromine has 7 valence electrons because it is in the 17th group. Now, element bromine is already stable. However, element magnesium still has 1 valence electron left. Notice class that our element bromine in the compound has a subscript of 2, which means there should be 2 Br elements. So let's add 1 more Br element. Okay, now they are both stable, completing the description of ionic bond. So they have an ionic bond. Do we all understand now how can we determine an ionic bond? Okay, that's good everyone. Now let's proceed to covalent bond. If in ionic bond we transfer electrons and covalent bond, this is the process in which sharing of electrons occur between 2 non-metal elements. Notice class that it specifically says here sharing of valence electrons between 2 non-metal elements. So let's have here our example. The compound HF or hydrogen fluoride. Let's see our periodic table. The element hydrogen belong to a non-metal group even though it is grouped in the metal group. Likewise with our element fluoride, a non-metal. So, let's see how they share their valence electrons through Lewis dot structure. Our element hydrogen has 1 valence electron, while our fluoride or fluorine has 7 valence electron. Our fluorine need 1 more valence electron to satisfy the octet rule, while our element H need also 1 more valence electron to satisfy the duet rule, as we said earlier that they are exemptions on the octet rule. So to satisfy both needs, they need to share valence electron, not to transfer valence electrons. Now, that's it. Let's have another example. The compound HCl or hydrogen chloride. The element hydrogen again belong to a non-metal group. Likewise with element Cl or chloride. Now again, element hydrogen has 1 valence electron, while chloride has also 7 valence electron. Again, to fulfill both condition of element hydrogen, which is duet rule, and element chloride, which is octet rule, they need to share valence electron. So as you can see in the video, the hydrogen completed the condition of having 2 valence electron and chloride having 8 valence electron. So, now they are both stable and follow the description of covalent bond. Do we all understand now, class, how to determine covalent bond? Okay, very good everyone. That is for our discussion today, and let's have Teacher Avon for a short evaluation if you really understand our lesson for today.
Now, let's test your understanding with a few quick evaluation questions. I'll ask a question and I'll give you 20 seconds to think about your answer in each number. Determine if the sentence describes an ionic bond or is it covalent bond. Okay, are you ready? Here's the first question. This involves the sharing of electrons. Number 2. This occurs between a metal and a non-metal. Number 3. This occurs between two non-metal. Number 4. It involves the transfer of electrons. Pause the video now and think about your answer. Okay, that's all. Who got a perfect score? Good job to everyone. Now, let us proceed to the summary of our lesson today. What is ionic bond? So basically, Mom Janiene said that this is the transfer of electrons that only occurs between metal and non-metal. So it is not very possible for two non-metals, unlike for covalent bond, wherein covalent bond is the sharing of electrons that only occurs between two non-metals. So, why is it important to learn about ionic and covalent bond? Let me explain this to you. Learning about ionic and covalent bond is important. Why? For better understanding the synthesis of organic compounds, the behavior of substances, and the formation of complex life essential molecules. So when we say synthesis, this is the act of combining different elements to create something new. And that is why it is very important for us to learn about the ionic and covalent bonds.